Good afternoon, and thanks for having me here. I really want to thank the committee. It's a real honor to have our work included in this really august collection of papers. I'm going to do something a little bit different than the previous speakers. I'm going to try to do a paper in 45 seconds, and then try to take lens advice and kind of reflect on what we understand from what we did. So our paper, PlaySlab, was the first to promote the idea of using the existing radios that are ambient in the environment as, Victor was saying, the radios that are there simply for communication, and use them for wide area location. So the only popular wide area location system at the time was GPS, and it didn't work indoors. And so our system had a pretty basic concept was that if you walked around or crowdsourced a map or out with the car with radios, you could build a map of all of the existing ambient radios for communication, working from the 8 to 11, Bluetooth, GSM, and by putting that map on the device, we can device access to the map by simply scanning for available radios, map simply to all these radios and unique IDs like MAC addresses. You can run a pretty simple weighting algorithm and estimate where your device is. Not as accurate as GPS, but of quite high coverage. That was kind of the work. Like the code work, we open sourced, and I think it was a real accelerant for impact. The work was rapidly commercialized by 3 or 4 companies, in some cases by co-authors on paper, and stepping back, 12 years later, and looking at it, and an interesting thing that kind of occurs to me is with location was sort of aggregate from other papers that have already been presented. Location was well understood to be one of the cornerstones of content awareness, super important. So why didn't this paper get written sooner? Algorithmically, it was not effective. We were doing simple weighted centroids. Location was already recognized as important. It's very smart for working in it.
Probably the best argument for why this wasn't done before was that radio densities had sort of only just, this is downtown Seattle, 2002, radio densities had only just gotten to the point where you could have near continuous coverage. Clearly in, rural areas, it still may not be the case. But I'd actually argue that that's not the case, that based on the data we collected, as of 2001, you probably could be running a system that would provide near ubiquitous coverage in most population centers. And so we did some thinking about this problem and why this took so long to happen, because I think history has proven that, that there was a real demand for this. There's a very large number of systems that are built, applications and services that make use of sort of modest accuracy, high coverage location. And so the first lesson that I really took away from this, and here I'm sort of speaking to the graduate students that are looking for problems, research problem selection. I'm trying to sort of level the lesson up to that level, is that your metrics are super, super important. We all love our metrics and our benchmarks. They take sort of the complexity of the world and reflect it down to one or a small number of numbers that make it very easy to measure, to present, and to compare to the results from the previous year. But we have to be really careful that our metrics carry an implicit judgment that the thing you're optimizing is what's important. And if the world has changed or your metrics are chosen wrong, you run the risk of optimizing things that actually wind up not being important. So, you could be like this poor unfortunate fellow in this cartoon who, drops his money, and he's not looking where he dropped the money, he's looking where the light is good. And of course, he's not going to find it. And that really was the case when we did this work in 2005. Coverage was very unimportant when it came to location systems. Really, accuracy was the only metric that anyone talked about. I think I owe Victor a beer for having actually demonstrated this point so well with his slides. Your graph showing the 15 systems, all you showed was accuracy across the whole thing. That's really, by 2005, the sort of core technologies for location had already sort of been invented, and most people that were publishing papers were just trying to do a slight algorithmic or sensing improvement on these stock systems. And to me personally, this always seemed backwards. To me, improving the accuracy of one of these existing excellent systems was like trying to improve the voice quality on a cell phone that only worked in, a half a dozen street corners. So as a result, we actually turned that really backwards in the place lab work. We published the accuracy, but we really made no serious attempt to improve it. For us, coverage was the key metric, and that was what we really tried to hammer home in the work. GPS covers the whole surface of the Earth, so we had to look at coverage a little differently. We opted to use coverage as a percentage of a person's day. That was our sort of core metric, and we did it in a couple of different ways. So we did a number of day-in-the-life studies. We used some hardware from Roy Want that was capable of measuring, Wi-Fi, GSM, GPS, and we had people put it in their purses or put it in their backpacks and take it through their day, and then after some time we would download the data and basically figure out, could the system have figured out where you were at that time, and come up with metrics that sort of said, GPS 4.5% coverage, GSM 99.6. This was hammering it home at the user level. We also wanted to look at radio rollout across different types of population centers. So we did look at sort of urban versus residential versus suburban. But I think sort of the key takeaway here is that you need to sort of look at the metric and make sure you're optimizing the thing that's actually going to drive adaptation. And I think, again, history has shown that the idea of building a system that is optimized for coverage was a good thing to do. I will say, though, that we actually got quite a bit of pushback on this research when we first put it out. There were a lot of criticisms in the original reviews and others, and that brought me to a second issue that I want to bring up, maybe caution people if this is the case in your technology, and that's to be aware that in the case of a technology that is primarily being driven by a single usage, where there's a real dominant usage, there can be a very strong bias on the technology from that single usage. So in 2005, the primary use for wide area location, not inside of a building, we've seen many, many great applications for location inside of a hospital or a factory or a classroom. But once you got outdoors, turn-by-turn driving direction was 99% of what people talked about. And some research wonks had figured out that 10 meters of accuracy was required for turn-by-turn driving directions. And if you couldn't deliver 10 meters of accuracy, your wide area location system was not going to be useful. And that was the criticism we got. We were in sort of the 18 to 25 meter range of accuracy, and so we got a lot of criticism. There's a picture here, of a creosote bush. This grows in the American Southwest, and this is a bush that produces toxins that basically poison the ground around it, so nothing can grow near it. And for us, turn-by-turn driving directions really was the sort of creosote bush for wide area location. And as a result, we actually did no actual further optimization of the place lab system. Most of the subsequent papers that we produced were building services and applications, location-based reminders, some social networking applications to actually show that always on location, even if the accuracy is modest, actually has a lot of value to try to sort of overcome this bias. There were others clearly working in this space too. And again, I think history has showed that there's an enormous, we got a list here. Actually, Victor's list was better. This is a sort of enormous list of usages now for this. It seems very obvious in retrospect that a system that knows where you are all the time on all your devices would be great, but at the time, actually, it was a little controversial. And with that, I'm going to hand it to my co-author, who's going to finish up with his observations.
Next slide. Thank you, Anthony. And I want to thank the awards committee as well for this great honor. It's fantastic to be up here on stage. So I want to just share one last thing from my point of view, which was a personal lesson I took from this work in the hope that it might be useful as well, which is around the value of simplicity. So the technical approach in PlaceLab, as Anthony's already mentioned, was pretty simple. But it turns out that I think that simplicity has some key advantages, which led it to sort of being here today, surviving the test of time. I mean, first of all, a simple idea is often easier to scale, and by that I mean scale in terms of another person copying, reusing, building on your work, company picking up and integrating it into implementations. Obviously, if it's complicated, then that comes with, code maintenance issues and so on, and it's harder to maintain over time. The other thing about simplicity is a simple algorithm is less likely to overfit on the test scenarios. And I'm certainly guilty of this. I'm sure many of you will recognize the same, where you build some algorithm or system, you've got a test scenario, you've concocted an experiment that you run it against, and clearly you're like, well, I can tweak it, I can add this thing and that thing, and you end up overfitting, perhaps, on that particular test scenario in a way that maybe doesn't help that system that you built get out there and be deployed and stand the test of time. So for me, that was one of the lessons of this project. And another way of putting it is to find a novel approach, spend your time on finding a novel approach, as Anthony discussed, rather than finding a complex solution. And I'll just end with a couple of examples there. I won't go into them, but these are other projects. The SenseCam is a project that won the 10-year Impact Award at MobiCom this year, a couple of weeks ago. And Open Data Kit is a project led by Gaetano Borriello, one of the co-authors on this paper, who's sadly not with us now. But both, for me, are examples of systems that are really technically very simple, almost embarrassingly simple in some ways, but have had huge impact. Thank you very much.